Go, take two. It's actually screen recording, so you don't have to see me do this. So you spend a lot of time fixing your file. I've got iHeart Alaska without as many nodes as going into the laser cutter or vinyl cutter. So these have been enlarged out. I made a 6mm circle that I can drag around, see will it fit in here. It looks like it should. Should not be just barely, but I think that'll be good enough. We'll know a little bit later. Down here, it goes in. I can get some detail. Now, I'm going to lose this detail in here. I can't get into there. It's okay. I'll just go, I'll do the best we can. We'll come in here and we'll just recognize that that's going to not actually work. But we'll come close. So I've got my smoothed state. I have this actually the size that I want it, that I'm going to cut it. So I've made this be around 200 by 200 millimeters. And if you import this into Fusion 360, it doesn't import exactly the right size. So we're going to make a place for it to go that is 200 by 200 and then just make sure that we're close. If you need something imported that's an exact size, you have to do a little math and figure out what the actual enlargement ratio is. And I'm still working to try to figure out what happens when you go from an SGV file into it. It's close, but it isn't perfect. You can look on the path editor and you can see the number of nodes. I've greatly reduced them doing the simplify operation, Control L, got it down, and then it took a little while going around, smoothing things out, making it look real nice. So I'm pretty happy with how this is going to be. It's what I want, and it won't be too many. If you have too many nodes, it's going to crash your Fusion 360 program. Just had a teacher come and tell me they tried to do something today and it didn't work. So you've opened Fusion 360 and we have to create the shape in here. So we're going to make a new sketch, and again you have three places to choose. If you choose this XY plane, you'll have a lot fewer problems as far as setting up the router origin for the work coordinate system. So select this plane, green and red, and we're going to make a simple rectangle. Again, we're going to make the rectangle the size that I want to work with here. So 200 by 200 millimeters. If you need something bigger, you can use it. This is a good size for starting things out right now. And I will know that my imported shape will fit in there. I'll get a good feel for how big it is. I made the SVG. I have to insert the SVG. Finding the file. This is the one I made for the router, and it comes in at the 0, 0 axis, so I've got to move it around and drag it up, so it's not quite right where I want it, but it's pretty easy to move it. So you just grab this little handle and bring it up, and if you want to resize it, there's a handle here to resize it, bigger, smaller, but I want it to be fitting the 200 by 200 square, and it looks pretty good right there, so I'm gonna, it doesn't matter where it is because the squares is just for sizing references. So I've inserted it and I'm done. That's all I have to do on the sketching. I'm going to show you in the isometric what happens. I'm just going to extrude this 5 millimeters, and there's my part. That's what the wooden piece is going to look like if I want to cut out the eye and the heart. I'm not going to do the eye and the heart today, but they're there if I want to do it. So this is it. I'm done in the modeling environment. Come over here and there's these other environments to work with. CAM creates the toolpaths. So it's for designing something to be built with a CNC machine. Computer aided manufacturing. So here's my CAM environment. Different choices along the menu ribbon. First thing that you have to do one time, and that's under the Manage the Tool Library. You don't have the library, you don't have the tools that we own here at the SAS Fab Lab. They're in here. Put them in the local library, my SAS tooling. I make a copy of this. I have it on a flash drive. I've also uploaded it on the Google Drive for this course. But right-click under Local and import the tool library. So get the flash drive, get it from the Google Drive. It's a compressed file, import that library, and you'll have all the tools and the right numbers for what we're using here. That will get updated on occasion. When I break a tool, I have to put a new one in, but this will do what we need to do for the router especially. We're going to be using tool number 92 here. So my tools are there. Hopefully you can put yours in. And there's two things you have to do. We have to do a setup, and then we have to create the toolpath. So setup, toolpath, and then we're going to simulate it, and then we're going to post-process it. So the first thing to do is create a new setup. When you do this, if you did the operation on the XY axes, and you put the state right in the middle, this triad, this is the work origin for where the machine is going to start. The machine can start wherever it wants to on the actual machine bed, but as far as what you're going to cut, this is 0, 0, 0 for when you set the origin of the machine. So it can be down here, you can move that. X is to the right, Y is north-south, Z is perpendicular to the actual flat surface, which is perfect. Don't go onto the bottom, because if you go onto the bottom, then Z's are all positive, and I want 0, 0, 0 to be right here. I actually want 0, 0, 25.4 to be 1 inch above that, so I can check that I really am going to be 1 inch above when I think I'm 1 inch above, to keep bad things from happening, like breaking the machine. So there's the work coordinate system origin. It's a box point, and I've chosen the right one. It was there right away. The other thing you have to do is define the stock. Because I built it as just 5 millimeters, there's actually no additional stock, and so the height of the stock is 5 millimeters, and I'm okay with that. So my setup now has the coordinate system defined and how thick the stock is. The operation that we're going to do is a 2D contour. It simply goes around a path that is defined on your shape. So a 2D contour, there's 5 steps to go through on the tabs here. We only need to do the first 3 for the contour, and the first part is selecting the tool. You've imported the tool, it's in your SAS library, it's tool 92. There's a 6 millimeter 2-flute end mill for the router. So that is all defined, and it will work perfectly for you here. The speed is set, the feed rate is set, lead in, lead out, plunging feed rate, those are all set up to work as they should for cutting 5 millimeter MDF. It's a fairly stout tool. Chances, we've broken a couple of them here, but with luck we'll be able to manage the class activity without breaking anything. Then you have to choose the geometry that you want to cut around. If I cut around the top side, nothing will get cut unless I move it an additional offset below this. If I cut along the bottom, it's going to cut right to the bottom of the state and cut the 5 millimeter shape out. And so that's the tool, the geometry contour that I want to choose. The third thing is the heights that I'm going to cut it at. The bottom of the tool, if I go just around the contour, it might not cut all the way off because it doesn't get quite all the way through it. So I go into the spoil board and below the 5 millimeter MDF by an additional 0.5 millimeter, 0.5 millimeters. Now I'm going to cut in the spoil board just a little bit, and we'll actually see where everybody cut because we're going to go down an additional 0.5 millimeter. Now you click OK, the toolpath is generated, and this blue line is where the center of the cutting tool goes. It's going to drop down right in the cook inlet, cut around here. Smart people, you're going to know how far apart this is. Well, the tool is 6 millimeters. I want to cut this edge, so the offset is an outside 3 millimeter offset. And you can see I do get in here, I don't get in here. I do get in over here and cut that out. Seward Peninsula is going to come out nice. Cook Inlet's going to come out nice. And so there's my toolpath. To see how it actually operates, it's really a good check and almost mandatory that you do a simulation of it. You turn on the stock, that's what it thinks it's cutting. We're actually going to be cutting from a much larger piece. Run the simulation, and there's the cut, and this will be what your shape's going to look like. And here you can decide, is there enough detail, or do I have to go back and redo a lot of the work that was done with Inkscape earlier, but looks like Alaska to me, and I'm going to be happy with this operation. I'm not cutting the eye and the heart right now. We can deal with that later. It might be nice to say, hey, can you cut out just a small amount, go down 2 millimeters and cut that out the heart? That would be a different operation. That would be a great summative assessment question. So there's the simulation. I'm going to post-process it now. The post-processing is what sets up the G-code for the actual machine that we're using. This is a Mach 3 mil controller on the CNC router. So we ordered it with, there's different kinds, but Mach 3 mil is one that is easy to use. So you have to go through the list and find Mach 3 mil. When you choose it once, it should stay there. It's going to be in millimeters. It's going to open this program called brackets when it's done. And so I'm doing Alaska for CNC take 2 because the first one didn't record the screen. And so now brackets is opening up. And there's a few modifications that have to be done to this actual G-code program. First thing is up here at the top, get rid of the G49. That is something that deals with the tool offsets. And get rid of G28. The G28 command takes it back to the machine origin. You don't want to do that. The limit switches sometimes don't work. After choosing the tool and making sure the right tool is in there, set up the safety check so that we know that we're at the beginning. So we're going to go 1 inch above, and we're going to pause with an M0 command to make sure that the tool goes to the middle of the state 1 inch above before we start cutting. At the end of the program, cuts the last little shape, goes up to Z15. I'm going to have it go back to the origin, Y0, X0, and Z25.4. M9 shuts off the coolant, get rid of the G28, get rid of the G28, and have an M5 command makes the spindle turn off, and now we're set to save this and take it on a flash drive to the CNC router. So we'll see you over there, and with any luck, you got a good toolpath that'll cut exactly what you want.